Few aircraft embody longevity like the B-52 Stratafortress, first flown in the 1950s. It's still on the front line today, and now it's getting a new lease on life. The U.S. Air Force has chosen Rolls-Royce Phone 30 engines to replace the aging TF33s, setting the bomber up for service well into the 2050s. But why re-engine a 1950s airframe instead of replacing it? How do the Phone 30s change performance, cost, and what ripple effects could this program have across the aviation industry? Let's break it all down. The answer is simple: the old engines are running out of road. The Pratt Whitney TF33 first powered the B-52 in the early 1960s, and 6 decades later, parts are scarce, maintenance is expensive, and reliability is declining. Every year, keeping these engines airworthy consumes more manpower and resources, eroding readiness across the fleet. Enter the Rolls-Royce Phone 30, based on a proven commercial core and modified for military duty. These engines offer modern efficiency, durability, and thrust. Crucially, the Air Force retained the traditional 8-engine layout. Switching to 4 larger engines would have demanded a complete wing redesign. New pylons and flight control overhauls risks the service wanted to avoid. Keeping 8 engines allows structural changes that are challenging but manageable while maintaining safety and certification pathways. Performance. More thrust means shorter takeoff distances, higher climb rates, and better payload flexibility. High-altitude cruise improves, giving planners more routing options and heavier payload capacity. Fuel efficiency. Fuel consumption drops roughly 40% on intercontinental missions. Fewer tanker sorties are needed, cutting operational costs and logistical strain. Maintenance. The TF33 predates digital diagnostics. The Phone 30 supports modular cores, predictive health monitoring, and digital tools, reducing unscheduled maintenance and keeping engines on wing longer. Controls and durability. Full authority digital engine control simplifies handling and optimizes performance. Advanced alloys and composites improve thermal tolerance and reduce wear. Environmental impact. Lower fuel burn reduces emissions, and the engine meets modern standards for smoke particulates. And nitrogen oxides. He decision to stick with 8 engines, avoids costly wing redesigns, and preserves aerodynamic behavior. Spirit Aerosystems is supplying new struts and nacelles, shortening pylons, reducing drag, and adapting the Phone 30 dimensions to the existing wing. Cockpit instruments and avionics are updated in parallel, giving crews modern, consistent systems that simplify training and enhance situational awareness. Ground trials at Stennis Space Center have tested performance, endurance, and environmental limits. Integration involves progressive flight tests from basic handling to high-power long-endurance sorties. The Phone 30 is quieter and cleaner than the TF33, eliminating the signature black exhaust plume while improving operational stealth and environmental performance. Harsh cold weather at Minot Air Force Base exposed the cost of ice and debris buildup. Between 2021 and 2023, 10 engines were damaged, totaling $17 million in repairs. A $1.2 million investment in flexible engine pod covers prevents ice accumulation and speeds up winter turnarounds, reclaiming an estimated 7,500 maintenance hours annually. Dramatic boost to readiness. The B-52's longevity isn't a fluke. It delivers long-range reach, heavy payloads, and global deterrence capability. It's flexible, shifting from carpet bombing in Vietnam to precision strikes in Desert Storm, maritime surveillance, cruise missile deployment, and future hypersonic weapons cost efficiency. Compared to stealth bombers like the B-2 or B-21, the B-52J is cheaper to operate with lower fuel and maintenance costs. This makes it the workhorse of the fleet, ideal for routine missions, training, and allied exercises. Fleet strategy. The Air Force envisions a layered bomber force, the stealthy B-21 for high-end penetration, and the B-5 to J-4 capacity, endurance, and routine missions. The program sustains thousands of jobs from Rolls-Royce's Indianapolis facility to Spirit Aerosystems and downstream maintenance depots. Digital controls, advanced materials, and predictive diagnostics developed for the Phone 30 will inform next-generation civil engines, reducing operating costs for airlines and enhancing reliability. Re-engineering proves that extending the life of a proven airframe can be more cost-effective than full replacement. a lesson applicable to both military and civilian aviation. The B-52J program faces funding gaps, integration unknowns, and supply chain challenges. Introducing modern engines to a 1950s airframe requires careful validation of structural loads, vibration, and aerodynamic interactions. Delays in parts or testing could ripple across depots and squadrons, risking readiness and congressional support. Program success hinges on three linked factors: stable funding, seamless integration, and reliable fielding. Each is essential to ensure the B-52J remains a core part of the fleet through the 2050s. The Rolls-Royce Phone. 30 engines give the B-5 new life: lower fuel use, extended range, easier maintenance, and improved performance. The B-52J isn't a relic. It's a capable, flexible, and cost-effective platform set to remain a cornerstone of U.S. strategic and conventional air power for decades. The program drives technology, preserves aerospace expertise, and sets a blueprint for sustainable, cost-conscious modernization in aviation. For deep dives on major aviation programs and the tech shaping the skies, subscribe and turn on notifications to stay updated. Few aircraft embody longevity quite like the B-52 Stratafortress. First flown in the 1950s, it's still a frontline bomber today and now. It's about to enter a whole new chapter. The U.S. Air Force has selected Rolls-Royce Phone 30 engines to replace the aging TF33s, extending the B-52's operational life well into the 2050s. But why re-engine a 70-year-old airframe instead of replacing it entirely? How will the Phone 30 engines improve performance, cost efficiency, and sustainment? And what ripple effects could this program have across the entire aviation industry? Let's dive in. The B-52's Pratt Whitney TF33 engines have flown for 6 decades, a remarkable achievement, but their time is up. Parts are scarce, maintenance is increasingly expensive, and reliability has declined. Keeping the TF33 fleet airworthy consumes massive resources and manpower, eroding readiness across the bomber force. The solution? The Rolls-Royce Phone 30, this engine derived from a proven commercial core and adapted for military service, promises modern efficiency, durability, and reliability. Critically, the Air Force decided to retain the B-52's traditional 8-engine layout. Moving to 4 larger engines would have required a complete wing redesign, new pylons, and flight control modifications, high-cost path the Air Force wanted to avoid. By keeping 8, engineers can integrate the Phone 30s with structural modifications that are challenging but manageable. While preserving safety margins and existing certification pathways, the benefits of the Phone 30 engines are substantial. Thrust, more raw power, translates into shorter takeoff distances, better climb rates, and increased payload flexibility. High altitude, cruise performance improves, giving mission planners more routing options and the ability to carry heavier payloads more efficiently. Long-range intercontinental missions will see fuel consumption drop by roughly 40% compared with the TF33. Fewer tanker refueling sorties are required, reducing strain on the supporting fleet and lowering overall operational costs. Maintenance and reliability. The TF33 predates modern maintenance practices. The Phone 30 introduces modular cores, predictive health monitoring, and digital diagnostic tools, allowing maintainers to catch potential issues before they become failures. This reduces downtime and extends engine on-wing life. Advanced controls and materials. Full authority digital engine control ensures precise management of thrust, fuel flow, and environmental parameters. Advanced alloys and composite materials improve thermal tolerance and durability. Even under demanding mission conditions, environmental impact, lower fuel burn reduces emissions, and the engines meet modern standards for smoke, particulates, and nitrogen oxides, while environmental compliance isn't the main driver. These improvements align with long-term sustainability goals. The decision to retain 8 engines wasn't just about preserving tradition. A Ferengian configuration would have required a complete wing redesign, new pylons, reinforced structures, and redesigned control surfaces, all adding years to the program and increasing certification risk. Spirit Aerosystems is producing new engine struts and nacelles. By shortening the pylons and bringing the nacelles closer to the wing, engineers reduce drag, improve weight distribution, and adapt the larger Phone 30s to the existing airframe. This redesign subtly alters the B-52's external lines, but is critical for performance and maintenability. Cockpit systems are upgraded in parallel. Pilots will have modern engine interfaces, digital displays, and integrated monitoring systems, reducing training complexity and enhancing situational awareness. Testing the Phone 30 engines is a multi-stage process. Ground trials at Stennis Space Center assess performance, endurance, and environmental limits. Integration involves careful flight tests, first handling checks, then high-power, long-duration sorties. This stepwise approach is essential for marrying modern engines with a 1950s airframe. Few aircraft symbolize longevity like the B-52 Stratafortress. First flown in the 1950s, it's still on the front line today. And now, it's getting a new lease on life. The United States Air Force has selected Rolls-Royce Phone 30 engines to replace the aging TF33s, setting the bomber up for service well into the 2050s. Why did the Air Force choose to re-engine a 1950s airframe instead of replacing it? What did the Phone 30s change for performance, cost, and sustainment? And how could this program ripple across the entire aviation industry? Let's break it all down. The B-52's commercial engine replacement program exists for one simple reason. The aircraft's current engines are running out of road. The Pratt Whitney TF33 first powered the bomber in the early 1960s, and those same engines are still flying today. After 6 decades of service, parts are scarce. Maintenance is expensive, and reliability is slipping. Each year, keeping the TF33 fleet airworthy consumes more resources and manpower, eroding readiness across the bomber force. The solution chosen by the United States Air Force is the Rolls-Royce Phone 30. This engine is based on a proven commercial core, modified for military duty. Importantly, the Air Force decided to keep the traditional layout of 8 engines on each bomber. That choice avoids the enormous risk of moving to 4 larger power plants, which would demand a complete redesign of the wing, pylons, and flight control systems. By keeping the count at 8, engineers can slot in the new engines with structural changes that are challenging but manageable, while retaining the safety margins and certification pathways that already exist. With the Phone 30, the B-52 gains the thrust efficiency and durability needed to keep flying into the 2050s. Officially, the Air Force expects the re-engineered aircraft to serve alongside the new B-21 Raider, providing a complementary mix of stealth and non-stealth bombers. The goal is to extend the B-52's service life by decades, stabilize its mission-capable rates, and keep the fleet available for global tasking without the chronic downtime that plagues the TF33 today. Progress, however, has been slower than first projected. Integration has proven more complex than anticipated, from structural adjustments to software and avionics tin. At the same time, funding shortages have constrained test pacing and slowed the flow of parts. As a result, the program's initial operational capability has slipped with the first frontline squadron of re-engined bombers not expected until around 2033. That delay matters, because every year the old engines stay in service. Maintenance costs continue to climb, and operational risk remains higher than the Air Force would like. When the new configuration finally reaches the flight line, it will carry a new designation, the B-52J. This label reflects the scale of change across the aircraft, while the engines are the centerpiece. They arrive alongside a broader modernization package that includes a new radar, updated cockpit systems, and digital avionics. Together, these upgrades ensure that the B-52 remains not just a flying relic, but a credible, capable, and sustainable platform for the 21st century. The most immediate change from the Rolls-Royce Phone 30 is raw performance. The new engines deliver more thrust than the aging TF33s, which directly improves takeoff margins, payload flexibility, and climb rates. For a heavy bomber, these gains translate into shorter runway requirements, better safety margins on hot or high-altitude bases, and more confidence when operating at maximum weight. That added power also improves high-altitude cruise capability, giving mission planners a wider range of options when routing flights or carrying larger payload. Fuel economy is just as important. The Air Force projects that the Phone 30 will cut fuel consumption by roughly 40%, compared with the TF33 over long intercontinental missions. That reduction expands unrefueled range and lowers the number of aerial refueling brackets required. Fewer tanker sorties mean less strain on the supporting fleet and lower overall logistics costs. For a bomber, often tasked with flying from the continental United States to overseas theaters, that efficiency compounds into more flexible planning and less operational risk. Maintenance is another decisive upgrade. The TF33 was designed in the 1950s, long before digital diagnostics or modular maintenance philosophies. In contrast, the Phone 30 is built around cores that can be swapped or serviced with far less downtime. Real-time health monitoring and predictive algorithms flag issues before they become failures and maintainers. Gain access to digital tools that optimize inspection intervals. This predictive approach extends the time each engine can stay on the wing and reduces unscheduled maintenance events, which historically have drained resources across B-52 squadrons. Control systems represent a leap forward as well. The Phone 30 is equipped with full authority digital engine control, which allows precise management of thrust, fuel flow, and environmental margins. For the flight crew, this means simplified engine handling and more consistent performance across the fleet. Advanced alloys and composite materials further expand thermal tolerance and durability, limiting wear and preserving efficiency even under demanding mission conditions. The combination of modern controls and materials directly enhances reliability, making the B-52J easier to operate and sustain than any earlier variant. The environmental profile of the re-engine bomber also shifts. Lower fuel burn translates into reduced emissions, and the Phone 30 incorporates combustion systems designed to meet modern standards on smoke, particulates, and nitrogen oxides. While environmental goals are not the driving force behind the upgrade, they are increasingly relevant for a fleet expected to remain in service for another 30 years, aligning military modernization with broader emissions. Reduction targets demonstrates how defense programs can intersect with sustainability policy. The choice to retain 8 engines rather than switch to 4 was deliberate. Moving to a 4-engine layout would have forced a complete redesign of the B-52 wing, including new pylons, strengthened structures, and major changes to control surfaces. That level of modification would have added years of design work, higher certification risk, and far greater cost by keeping the traditional 8-engine setup. Engineers can introduce new power plants while preserving the basic wing structure and aerodynamic behavior, giving the program a more predictable path to approval. The new engines require freshness and struts to house them. Spirit Aerosystems won the contract to supply both with the design, bringing the NLS closer to the wing on shorter pylons. This arrangement reduces drag, improves weight distribution, and adapts the larger Phone 30 dimensions to the existing wing platform. It also standardizes the pods across the fleet, simplifying maintenance and reducing the number of unique parts that must be supported. The redesign is a visible reminder that the reaming effort goes beyond swapping power plants. It alters the airframe's external lines in subtle but significant ways. Integration work does not stop at the NL. The cockpit must accommodate new engine instruments and interfaces. Since the digital FedEx system requires modern displays and updated controls, avionics are being refreshed in parallel, giving pilots access to more reliable monitoring systems and aligning the engine program with broader upgrades, already planned under the B-52J designation. Together, these changes ensure that flight crews interact with the aircraft through consistent, modernized systems, reducing training complexity and enhancing situational awareness. Testing is progressing across multiple venues. Rolls-Royce has already conducted Phone 30 trials at Stennis Space Center, focusing on performance, endurance, and environmental limits. These ground runs feed into the integration program, where airframe-specific systems, such as struts, nels, and cockpit teams, must prove their reliability before flight clearance. Once integration is validated, flight test plans call for progressive workups, from basic handling checks to high-power, long-endurance sorties. This stepwise approach is essential when modern engines are being paired with an airframe, design that dates back to the 1950s. Observers will notice differences once re-engineered aircraft take the field. The most obvious is acoustic. The Phone 30 is quieter, producing far less of the distinctive roar associated with the TF33. just as visible as the absence of the smoke trail that long characterized B-52 operations. For decades, the black exhaust plume was as recognizable as the bomber silhouette. But improved combustion efficiency means the B-52J will fly cleaner, quieter, and with a signature better suited for modern operations. For decades, crews at Minnow Air Force Base in North Dakota have battled brutal winters to keep the B-52 mission ready. Between 2021 and 2023, cold weather operations revealed just how